Okay, I think we're ready to go. Let's get started. This is the kernelci.org presentation and discussion, and we are the lucky ones to have the throw mic. So this is required to be interactive session because we have to practice throwing the mic around. So just so you know, we're going to go through a few slides, but we definitely want to make this interactive. We have a bunch of questions, and we're looking for feedback on this project. So first, we'll just go through a brief overview of what we're up to. So the kernelci.org is basically build and boot automation right now, and we'll build, boot, and test automation that we're working on. Primarily focused on upstream kernels. Our goal is to basically build all the configurations that are upstream for all the architectures. We're not doing all the architectures quite yet, but we're doing several. Boot the kernel on these configurations, execute tests, and do all of this every time a kernel changes. So we're doing several trees now: Linux Next, Mainline, the stable trees, LSK, several kernel maintainer trees that have asked us to do their trees. And this is a lot of builds, a lot of boots, and so the other goal here is actually to report things in some sensible way and usable way. So that's kind of the primary mission that we're on. The target audience has been basically, the initial audience has been kernel engineers, so that's why it's kernel CI, so kernel developers, kernel engineers, and people that are directly interacting with a moving target of a kernel. So the primary, the big why here is we want to make sure that the upstream kernels in the various branches are changing quite a bit, of course, and we want to make sure that as they change, they're not breaking in new ways, or they're not breaking in old ways, and then we also want to catch when they're breaking in new ways. So the primary goal is looking for gross regressions, things just stopping booting or stopping compiling and things like that. And that happens all the time in the upstream kernels, and historically it's been hard to capture these things in a useful way. And the other thing that this provides, because we have such a wide variety of hardware, this provides a way for other people that get a new board and they're trying to figure out how to boot it, what version of U-boot they need, what are the load addresses, what are the various bits they need to put together to get a board booting. They can go look for that board in kernelci.org and see a reference exactly how we boot that board, what bootloaders we use, what device tree we're using, all this kind of stuff. So it provides a reference for the community as well. So this kind of started among the ARM SoC maintainers, myself included. So we got to a point where, in trying to maintain a lot of the ARM platforms, it's really hard to check. It's really hard to find out when people are checking in code that it's breaking other platforms, and we'd find that out in kind of ad hoc ways. And we wanted a better way to actually discover if people are actually breaking other people's platforms, and including keeping their own platforms booting. And so Olaf and myself started writing some simple scripts and automating U-boot and stuff like that to get this stuff booting and testing on several platforms. And that was kind of the beginning. And then Tyler and Milo got involved, and we started making this more scalable, more useful. And then Milo especially was working on how to actually make the visualization of all this data and reporting of all this data actually usable. Because Olaf and I were just generating emails, and now we have the kernel CI front end that we'll show shortly here to actually look at all this data in a more usable and searchable way. So that's just kind of the background of where this came from. So the current status today, we have, kernelci.org is actually distributed, so we have several labs around the world that have a handful of boards each that report into this infrastructure. So we have x86 servers to small ARM platforms, and we're doing, for every kernel tree, we're doing about 400 to 500 boots every time for each kernel. So that's on the variety of hardware that we have. So what else is out there, and how does this compare? So some of you, the kernel developers out there, are probably familiar with ZeroDay, the Intel ZeroDay project, where sometimes Intel has this huge farm where they are actually doing lots of builds and boots as well, and you get email reports. If you have a tree out there and you push something in your tree and you break something, you'll get an email from this ZeroDay bot from Intel, They run all sorts of static analysis as well, sparse and things like that, and you'll get reports from that. And so that's a really good resource, and it's been really helpful to the kernel community. The problem with that right now is that there's no code available for that, so you can't actually reproduce that if you want to use that. It's only x86 VMs at the moment, and they're not publishing any of the artifacts. So we approached them hoping that we could use their builders and just use their builds and do the boots from there, but they're not actually publishing artifacts. And there's a few reasons. Part of it is legal reasons about publishing binaries and things, but it's also, I think, they're doing it so fast and at such a scale that it'd probably take them longer to push a kernel build than it would to build 100 more kernels. I mean, they just have a huge amount of hardware that they're throwing at this problem. So as a result, we're doing our own builds that are duplicating some of the work here, but we're making all the results public and publishing the logs and publishing the artifacts so that anybody that wants to suck them down and try to boot them can do that. So how is kernelci.org different? I guess I alluded to some of this. A big one is that it's distributed. So we designed it from the beginning to be able to have anybody that has a lab full of boards that wants to do boot testing could actually implement some of this infrastructure and push the results, and we'll collect them all and publish them. Most of the hardware, or most of the boards that we have are real hardware, so we're bootstrapping this from metal. We do some VMs. We have some x86 VMs. We're doing some ARM v8 VMs as well, but the vast majority it is bare metal. Everything is open source. We've been very interactive with the community. We've been doing talks at ELC and things like that and trying to get more feedback and get this project a little bit better known, and we're getting quite a bit of feedback. In fact, one of the labs that's contributing now is actually from Collabora. Those guys have a board farm running Lava, and they have their own set of boards. They have a lot of Chromebook development that they're doing, and they added all the boards in their Lava farm into kernel CI. So now one of the labs that's contributing all their boot results is the Collabora lab. Yeah, we're publishing all this stuff. Everything is searchable. We're also doing a lot with building all the kernel modules and also auto-loading all the modules. So when a platform boots, it's actually any modules that are for devices that have been probed are actually getting auto-loaded. So that's not, a lot of kernel developers aren't doing that. They're booting a platform without modules and testing stuff. This will actually build and test all the modules. And we've already found a handful of issues with modules that we're kind of hiding. So this is just some stats. We just recently crossed the 500,000 boots mark. We're doing, I mean, this is kind of average since, what was the average since? Since May of 2015. These are the numbers that, 2014. So on average, it's been about 1,000 kernel boots per day on these platforms. And the number of boards and the number of SOC families is what I like to brag about. I mean, this is really unique to have the same kernel booted across this many different boards and this many different SOC families is really unique. And in the ARM world, there's such a variety, and this barely even touches the variety that's out there. This is still, maybe 20% of the platforms that are actually in the kernel that we're testing. So that being said, the more that we spread this project, the more people are sending us hardware or asking us how to add their own labs added into this. So it's constantly expanding already.
So when you say 20% of the platforms out there, okay. When you say 20% of the platforms out there, how many are actually, how many can you actually compile into the single Z image out there?
I don't know. I actually haven't done that to see how many support multi-v7, but we're doing the multi-v7 def config as well as all the platform-specific def configs.
Okay.
So even if it doesn't support the single Z image, we still boot it if it's there.
I think 70% of the ARM platforms that we're booting now are multi-v7. But there's a handful that aren't in the multi-v7.
Okay.
So yeah, just some more numbers. On the bottom there's if you go to kernelci.org/stats, that's where these numbers came from, and those are constantly updated as we're pushing more stuff. I took these numbers this morning. So So in terms of def configs, we're basically any def config that's upstream, we're building it. We're also taking the upstream def configs and doing a few derivatives of it, like we're doing a multi-v7 with thumb2 kernel, or we're doing a multi-v7 with LPAE enabled. We're doing some, I guess we have the KVM one, the KVM configs that are in LSK are being added.
Are we doing something with the all the debug features and other stuff enabled?
We do a couple. We build the config proof locking one, so that'll blow up if there's locking issues during boot. And I've been kind of building this other debug fragment. Essentially turns on a whole pile of the kernel debug options, including the one that'll panic if there's any warnings, and that'll start to catch the more issues too. But
Awesome.
we haven't actually put that one in the main.
We were LPC. Andre Kolarov from Google was looking to get us to run the kernel sanitizer configurations as well. So we're going to look at that for x86, and eventually when that works for ARM, I'm just looking forward to those configurations.
So, in terms of reporting today, what we're doing is primarily build and boot testing. We started doing once we boot, we're actually running more tests, and these are the tests that we're running on a subset of the trees right now, a small kind of set of kernel-focused tests, Hackbench and cyclic test. The one we're focusing on quite a lot is the K-Selftest one, because there's a lot of movement in the community right now to actually get this in-kernel self-test framework into good shape and encourage people to actually write more tests in that framework. So we're focusing on that. Right now, our problem is, so we can run a lot of these tests. The problem is this is quite a lot of data, and we're working on actually how to visualize it in a usable way and make it searchable in a usable way. So we've been running these tests on Linux Next and mainline for a little while, cramming the database full of data, and now we're trying to figure out smart ways to visualize that. So this is one of the areas we're really looking for help. If people want to explore, scrub in the database looking for test results and help us generate interesting types of reports, we're definitely looking for help on that, or feedback, or for ideas.
So the database is searchable now, right? By board, by SOC type.
But that's just the boot.
No, that's the API where you can switch.
That's just the whole.
Okay.
Yeah. So what you got to throw it.
So are you putting everything really into the database? Because it sounds like something LTP and the hundreds of kernels you're testing, it would be an explosion of data in one database.
I did the calculation. There's 3,000 test cases in LTP times 450 platforms, like 1.3 million test case results every time we run LTP. So that's our problem, that we're trying to figure out how to make this not very noisy and how we can provide reasonable reports to developers that says, here's a new regression from this point to this point, and then just you're getting a little small chunk of that view that's actually relevant to and that's an actual regression. So that's kind of where we're at right now. We're trying to figure out intelligent ways to view this data because there's just so much of it. The other issue we have is long-running tests. LTP takes 3 hours. We're booting 1,000 boots per day. We've got 6 trees building, so there's a lot of time on the hardware. It's kind of a small window to run the test, so we need to be efficient when we do it. That's why K-Selftest is pretty good. It's about 30 minutes to run the whole K-Selftest.
My coffee just about lost it. Yeah, so how long does the full set take to run currently?
All of those tests?
Yeah.
I don't have an aggregate number, but K-Selftest is 30 minutes,
LTP is 3 hours. Hackbench and cyclic test can be configured based on what you want to do. CPU Freak libjpeg Turbo is about 9 to 10 minutes. LM Bench is pretty like 5 minutes. So I would say, if I would give an aggregate number off the top of my head, about 5 hours to run all of those tests per platform. So multiply that by 450. Now we do all of this in parallel, but the problem is then all the boot tests that we're trying to get quick results back kind of get blocked because we're running tests.
If you have like loads of hardware that can be
And that's kind of,
even LTP can be broken down into pieces.
yeah, and I think that's what we're kind of, when we first start running this at some kind of cadence, we're going to try to run it on the platforms that we have extra, so that we can kind of like dedicate a platform for just running tests while the other platforms are there for boot testing, see how that goes, and then if we can come up with a clever algorithm to schedule it on all the hardware, we'll implement that.
Turn on LKP yet?
No, we haven't, but I know that the QA team has done some good work there. I know Riku's been helping out and getting cross-compiling and working on ARM, so.
I'm not really sure if it's suitable.
So I think the bigger problem we have here is we can run a lot of tests and generate a lot of output. Sorry, you.
No, so the reason I brought up LKP is they have this concept of thresholds. So your problem is we only need to send the pertinent data to the developer, not the million records.
Exactly.
And so they have this concept of thresholds, so only those get sort of flagged.
Yeah.
So that's the only reason.
We need that general concept for all these types of tests because the problem is getting eyeballs to actually look at the problem once, and that's why right now we've been focusing on K-self-test because there's a lot of energy around that right now, and people are actually interested, especially our target audience, and it also will encourage kernel developers to actually write tests if they know they can go to a place and see, oh, the K-self-test failed on Linux Next, something's wrong, and so.
Yeah.
Well, and the other thing, the other reason to do case self-test is so it's easy for you guys to add tests. If you get your patches accepted, then they automatically get built and they automatically get tested, and then you can just view the results. I think that's the end goal for
Yeah,
case
so you don't have to wrap your test for some new framework. If you just get it in as a case self-test, it'll just get run on kernel CI.
Are you doing anything to catch performance regressions, or is it purely just pass-fail on tests?
Right now it's pass-fail tests, but the performance regressions are an interesting topic because we'd like to do benchmarking and performance, but at least inside Linaro, the feedback or the member feedback is, please don't publish any benchmarks from my platform and compare them to other members. So we have a bit of an issue there. We have to, and that's kind of a reporting issue, right? We can maybe say, okay, it's some percentage or something, but actually raw benchmark and performance numbers are a little more delicate.
But Olaf had an issue with this at ELC this year, saying that we don't want to publish that because Farnus is going to go and look at this and then start making inferences and writing articles about, oh, the performance is horrible in 4.3. You shouldn't use it.
But surely the interesting benchmarks is version to version on the same hardware to see if there's
exactly, So we want to give that type of delta thing, but so the reporting of that is it will be tricky, But it's on. It's
also get the issues with like running a benchmark on a platform that, for example, overheats and then performance regression because of those.
So all this testing stuff is really the big area that we want to work on next. But we definitely need help on that. John?
Oh, I was going to ask. One of the issues I'm having is so for case self-tests. There's kind of the different categories of tests that people have. So there's sort of the standard set, and then I've got a bunch of tests that I normally run, which I kind of set under the destructive tests because they're modifying time, and those are really the ones that I'm wanting to see results for, but it's not going to fall in sort of the standard test runs for safety. And so I don't know exactly how best to kind of enable that in your guys' runs, or how to kind of where the balance is for that sort of non-standard, quick checked sort of test.
So like as a developer, I just want to run these tests for me. Is that what you're getting at?
It's just kind of personally for you. You'd like to see these run. So that's not really something that we've thought about yet.
Or you want like a kind of a quick set of sanity checks in some category, and then also like a full test or something like that. You want to have some categories.
Yeah, well, I have that separation already. So there is sort of the quick test that doesn't modify. But then there's the ones where it's like, okay, we're going to start setting timers and changing the times.
Yeah.
Catch a lot of the actual interesting problems.
Those are the ones.
You don't want to have these that people just run and scrub machines, get it out of the normal state. Normal testing. But at the same time, the quick checks really aren't that interesting. And so I'm trying to find what the right balance is. I don't know how you get to deal with that sort of thing. I'm sure in other areas there's similar problems.
Yeah, we're not really dealing with it now, but we've talked about it because we definitely wanted to get to a point where we can have like for the platforms we want to keep active and we want to do stuff quick, we want to have a set of tests that we know are going to basically run quickly. And then for boards where we have lots of them, okay, then for those we want to enable like the stuff that's going to run a long time. But for us, it hasn't been like a category, it's more been about time.
So another interesting thing that I think Mitt and I talked about and is to actually have some case self-test that will identify the features that are present in the kernel. So we could eventually display that. You could go to the test result and say, for this platform with this kernel, does MMC work? Is there an Ethernet driver that's active and things like that? Does USB work? Those kind of things, because I don't think there's any way of aggregating that data currently.
Yeah.
Basically, generate a matrix.
Right, yeah.
Yeah, so was there another, I saw another hand someplace. Oh yeah, so this is just our classic, everybody likes to tell us the automation is easy, so it's kind of the lessons learned. There's always catches involved here. So yeah, so now we just kind of want to walk through the website itself. Tyler's going to kind of walk through the various features and show on the screen on the left. We'll have kind of the basic the stuff that we want to talk about. So start with the email report. So every build and every boot test, we generate an email report that goes to this kernel build reports email list. It's hosted on list.linaro.org. So it's just, yeah, so the example here is a mainline build that shows, basically which builds passed and failed, errors and warnings and stuff like that. So as you scroll down for all the def configs that had failures, there's links there that'll take you, it highlights the number of build warnings as well as errors. So yeah, these are just all the def configs.
There's a few warnings in there.
So there you can see, go up a little bit, you can see some of the config fragments that were used. So there's like multi-v7 with LPAE, with big endian, with that locking, with thumb2. So those are just some example options that we're adding.
Are these just the build information, or is it even the boot information?
So this is the build report email, and then there's also a boot report email. So the build, it takes about, what is it taking, about 20 minutes now to build all these 170 some def configs we're doing now. And then that build report will come out right as soon as that's done. And then a couple hours later, after all the labs have sucked down the results and boot tested and pushed them back up, then there'll be a boot report email that comes out. So then at the bottom, there's just kind of a summary. So a lot of times what happens, like if you look at the warnings summary, it's kind of sorted by the number of warnings. So a lot of times what happens, it's the same failure, the same warning that's showing up across a whole bunch of different platforms. So this kind of gets sorted and says that that particular warning is hitting a bunch of different builds.
So the error you have there is really, really annoying. It's supposed to have been fixed a while ago. Would it be possible for you guys to badger people if they don't fix it? Because Mark Brown is pretty.
I was going to say Mark Brown is the one that's doing that currently.
Yeah, well, I mean, Mark's builds are kind of pushing into. Is Mark? Oh yeah, there's Mark. Okay, you can speak for it. Throw Mark the box.
All right, ready, Mark? Sorry.
Yeah, it's also spilled water all over my laptop.
Oh.
Uh-oh.
Okay, maybe we should throw it around.
Yeah, or ask before people are, if people are ready to get it before you throw it.
Sorry.
People want me to say something?
Yeah. Will was just asking about the nagging factor of the build
Right.
failures. Yeah.
So yeah, no, that's pretty effective usually. When somebody actually follows up, yeah, those build failures there are really irritating. I went and spoke to Olaf this morning.
And you're still having to actually send the email report out and then reply saying this has been here.
Yeah.
And then people respond, right?
Well, some people do just fix things when they come up. I tend to leave it, unless it's really crap, I tend to leave it for a day or two. If it's annoying me immediately, then I'll tend to follow up quickly, or if it seems urgent. But there are people who pay attention to this stuff and or follow up of their own accord. And obviously, a lot of this stuff will also get caught by Fengguang's system, which will email people directly anyway. So the manual follow-ups are mostly for, this has been sitting here for a while, why aren't you doing something about it, sort of stuff.
So is there any interest in us sending the emails there since Mark's already doing it?
Yeah. Well, I mean.
Well, I kind of want to stop sending my build reports.
But I think the follow-ups, like the human factor, helps.
Yeah, the human factor definitely helps. And then I've been doing more nagging on the boot report side, and Mark's been doing more nagging on the build side. But then ZeroDay also kicks in too, and usually reports these things. But I don't know how to, for these ones that are long-lasting, I don't know how to do it. The problem is it just takes time. It takes somebody actually looking at it every day and realizing, oh my, this is still here. I got to nag this person again and again.
Yeah.
And it's kind of a.
It was good if you've got multiple people now.
Yeah.
Because it's not just specific to this test.
Yeah. That's true. Yeah.
So for this warnings and error summary, one of our issues we've had was, like for this specific error, what def config was it built under?
Oh yeah. So if you go up to, once you click on the, if we maybe Tyler can do that. So this is just kind of a summary of all the issues. But then if you go up to the specific ones, you can. If you go up to the boot report itself, I think you can find. So he's asking if you go to that, we have that warning right there. How would you find out which def configs are actually having that error?
Okay, so you can click on the warnings link here.
Yeah.
Yeah, sure, we'll do this one. This will take you directly to the actual build output with the warnings in it. Now, if you, let's go back here.
And you can't see the URL, but the URL has the def config and the kernel and all that stuff.
Oops, that's the boot report. Another interesting one, you can, let's just do the boot report. Let's see, if you click on the def config here, it'll take you to the summary here. If you scroll down, it'll also give you a bisection point. We'll get to that in a little bit. But you can go directly to the build log here as well. And this tells you what compiler we used and all that stuff for you the ability to reproduce it, how long it took, those kind of things. So go back again. Here, the build summary report, there's an HTML version that kind of breaks this down. It might be easier to sort. So you can show me builds with warnings and no errors, builds with errors and no warnings, and you can kind of filter those down here. Also, you can see all the def configs we built, just the successful ones or the failed ones. And if you click on this, you get a little warning and error summary. It'll take you to the same page here where you can see the breakdown.
So yeah, maybe we should just go back to the main page of the front end and show the couple of the tabs we have. So the home page for kernelci.org right now is basically a combination. It lists the most recent failed builds, and a little bit below it lists the most recent failed boots. So that's interesting when you're looking for if you know your build is the latest one through, you can have a quick look here. But more often, probably at least for this audience, what's more interesting is the jobs page. So the jobs page on the left, can you blow that up a little bit? Sure. So down the left lists all the trees that are being built. So you see some trees, Mark's trees were the most recent ones through the list. There's Andy Gross's trees, the Qualcomm maintainer, the Collabra tree, there's Russell King's tree, there's Mainline and Stable trees, and all these things. There's quite a few trees that we're building. I don't know, what are we up to for the number of trees that we actually monitor now?
I think we're, what is it, the last 23?
Yeah, so anyway, we're...
So is it broken down by def config, and then under def config there are a bunch of boards for that particular def config?
Yep. That's the boot report will break down for you. But this is like a top level view, so you can see what the builds that we're passing, the builds that are failing, the number of boots that are passing, and the number of builds or boots that are failing, and then you can kind of click down and so if we go to mainline here and we do the boot report, if you click on this little link here, it'll take you to the summary of mainline. So this is all of the boot reports for mainline, and it's the last 20 because we do a whole bunch, so we don't want to display all of it. And if you click a certain one, you can actually go dig deeper into it. So this is a specific view for the boot testing that we do. And what we're trying to do is just show the failures, but allow you to go and dig deeper. So to keep the noise down, we just want to show the platforms that are failing. So this is what it looks like. Again, there are the def configs here that you can tell what def config is built. And then the platform, and so we find an interesting one.
So it's grouped first of all by lab. You can see the Cambridge lab and Collabra lab and my lab. And then it's grouped by board, and then for each board you can see the def config.
So if you click on more info here, this is tell you what load addresses we use, what device tree.
what configuration, what the git describe was for the kernel that we built. Also, we have a nice formatted HTML log that you can look through and actually see all of the output. Back here.
Are you tracking the size of the image as well?
We are. Yeah, we're doing text. I have a patch for text ESS module size. So we could eventually start doing that. We also track the boot time, so we can start to graph that over time as well for each platform. And so if you go down here to other boot reports, this will show you, and this is kind of interesting actually, so we have multiple labs have the same hardware. And so sometimes we get what we call conflicts where it works in one lab but maybe fails in other labs. And so it's just interesting to kind of highlight those issues because they usually need a manual review to understand what the differences are. And so this view will show you the Collaborative lab passed this board, this boot test. My lab failed it. And then you can also get a comparison to Next. So if you're wondering if there's a fix pending that hasn't hit mainline yet, you can look and see, well, it looks like there's still the same problem in Next. So if you go down a little bit further, it gives you a bisection point so that you can bisect this. If you click this little handy button here, it'll kind of generate the starting point for your bisection script. But it may be down a little bit.
Excuse me, how do you know which compiler version was used to build these? How do you know which compiler toolchain version was used for these builds?
That's a good question. So if you click on the build details right here, and we were to go to that particular def config, I'll show you these are good. So multi-v7 def config right here. If you click that little icon, it'll take you to the build page for that particular def config, which then lists the compiler and the cross-compiler prefix we were using.
Is there any way to register actually to mail notification for the subset of data? In some sense, I don't know, like silicon vendor actually just want to know about jet build failures for that particular thing, or kind of like I'm interested, like for example, big Indian platform actually breaks or stuff like that.
Sure, let me show you. So typically what we usually do, the front end is searchable. So what I would do in that case, I'd go to the boot page. I'll show you here. What's that? Is it going to take a long time to load?
Are you thinking also like RSS, like feed notification kind of thing, or whatever? Yeah.
Just otherwise, I just supporting that. Right? I'm not interested in subscribing to the whole mailing list for all the trailers.
But just for a subset of it.
But if you just want to know, for example, like for silicon vendor wants to know trailers,
so just put in OMAP4 or something in the search box.
Well, so like here's ARM64 in the search box here when it updates. So there's all the ARM64 platforms. So if we did big, yeah, there you go. There's the big Indian configurations. I think we have to do this. Yeah.
This is gray area, right? What about actually kind of identification?
So this shows actually you can query actually and filter actually by certain actually stuff, right? But I was wondering actually, is it possible to register some email or mailing list that so you would guys actually send notification to that, right?
Yeah,
for specific set of attributes, right? And maybe actually another sort of like, but more theoretical question actually, is there any programmatic API actually to go and actually pull this stuff, right? Otherwise, like you need to go and actually parse all these actually web pages. It may not be friendly.
So we have different views for the board. So if we click like the Mustang board, you have excuse me, oops, there it is. You can get all the results for a particular platform sorted, and it's a simple URL to go to. Now we don't have anything that you can register with to get notifications about specific configurations and specific platforms. If there's enough interest in that, I suppose that's something that we could look at if that's helpful. But yeah, you can use these kind of views, and you can also query. You can create a query for the boot view just to filter down exactly what you want to look to. But unfortunately, you have to go to a web page and still look at that.
We did talk about, I mean, we've discussed a couple times when this has come up of doing maybe some sort of RSS feed that's, configurable with parameters where you could get your board or your def config or your platform or something.
We actually have support for RSS feed. It's just not enabled. Yeah.
Okay.
Yeah.
All right. What do you want to show next?
You want to show something about Lava? Or how are we doing on time? Or just do the self-test maybe?
Well, I think we're getting a little low on time. I think what we should do is we should show the new comparison feature. And this is something that we've been working on. So the idea is we're starting to do this testing.
we've got all these build and boot results, but what we're having problems with is trying to find out the deltas, right? I want to know the deltas between two trees. Maybe it's mainline and next, or it's two versions of your own tree to find out what's breaking. So Milo's been working on this comparison view, which I'll give you guys a quick demo for. So up here, this is beta right now. You would select the comparison for job, tree. We're going to compare mainline. Is you able to see that all right? We'll grab one of the latest versions of 4.3 versus next, and we'll grab the latest version of next. So what this does is that you provided a baseline tree, and you're comparing results against another tree, which in this case is Linux Next. And so what this shows you is a breakdown of what's the actual differences. Now, right now, it's only showing build data. Eventually, we're going to extend this to boot data and test data, so we can get a breakdown of n number of trees. So you can say, here's my baseline tree, and I want to compare it against stable, any other trees you'd like, and you kind of get a little breakdown like this, just to help visualize where the differences are. So in this particular example, you can see all mod config on ARM is building fine, but in Next it's broken. So that would be something that we need to go look at. Whereas all mod config ARM64 is broken in mainline, but it's building in Next, so there's already a fix pending most likely. Any questions about this view? This is something that we just put together and we've been working on for a while. So if there's any other suggestions you guys have to make this a little clearer.
Can I get email reports for these?
Okay. Is that something that you'd be?
What did you? What was the question? Email reports for the compare site?
So if I could set up some of these comparisons and make sure that, let's say, all
I think the email reports, what we want to do is we'll probably evolve the email reports once this is in better case. The email reports, the top part of the email report will highlight all the stuff that's just new, only the brand new failures and stuff. And so I think that's where we want to get to the point where it's really this delta stuff that really matters, because that brings the noise level way down.
Sure.
Yeah, another thing that this would be handy is for bisections. Eventually, we have the ability to bisect pretty much everything that we do right now, but it's a manual process. So it's Kevin and I saying, hey, that looks interesting. That looks like a new failure. Let's go ahead and run it through the bisection scripts. It would be neat to trigger this automatically from the delta. It's like, hey, now there's a new failure in Next compared to the last version of Next. Go ahead and just kick the bisection off and send out an email with the bisection log.
The bisection is semi-automated. Like once we decide that we want to bisect from here to here, we kick it off, and it'll go and find the right board and do that all. But still, it's usually we decide this needs bisecting.
I mean, why do you need to do bisecting? I guess you still need to have the same concept, but you don't need to build anymore, right? Because you already have the data for all those.
Well,
builds?
we only have the builds at the points. We want to build everything. When you bisect, you want to build everything in between.
But you had all these. We
didn't have everything in between.
Not necessarily. Yeah. I mean,
between like, for example, between today's Next and between yesterday's Next, there's a whole pile of commits. We have the data for the 2 days, but we don't have all the builds.
Oh, so this doesn't happen for every commit?
We're not building on every commit. No, we're building on every basically branch update.
Okay.
Can you bisect from 2 Next?
Yep. Well, no. I mean, you can. It's not terribly useful. Usually, what we do if there's a failure Next is we bisect against mainline. Whatever the merge base between mainline and Next is, we'll start from there.
Do you run all the testing bisection?
We're bisecting. We're only automatically bisecting boot failures right now.
So here's the latest bisection as of today. This is an issue with one of the Broadcom platforms we recently got in Linux Next, and so I can show you. So this is what it does. The neat part about the bisection is any lab that's a part of it, I can actually bisect remotely on the hardware. So even if it's not in my personal lab, I can also send it to the Collabor lab and bisect it, because they have platforms that we don't. Is there anybody in this room that wrote this commit? Sorry to throw it if there is. Let's see, I don't know. I think this is okay, so let me show you how this kind of works. Let's get back to the parameters that we used here. So it's a pretty simple interface. You basically say, what architecture, what do you want to do? There's a boot bisection. What tree, what branch, what def config do you want to bisect? We can also bisect the fragment, so multi-v7 plus config proof lock. So you can add that in there as well. You've got a spot for a bad commit and a good commit. So this is, like Tim, I think you asked this, how do we bisect Linux next? So this is an example of bisecting Linux next, but from a 4.2 tab. So coming in from the main line to Linux next. And then on the device, so if I were to go to here to kick off the other one, of course I'm not logged in. Click build with parameters. You get a little handy drop-down list of all the different platforms that we can bisect up. So it's pretty simple for somebody to come in here, plug values in, click go. It does all the builds. It will submit the boot tests. It'll pull them, find out the status, and then kind of work its way through it. It's been pretty reliable.
And then at the end of the output of this, you'll see the output of essentially the output of git bisect log. So you'll see basically all the whole steps.
This is it here. Yeah. So the very bottom here is yeah. And then there's the bad commit it's pointing at. So then typically what we do next is revert it on top of next. If it fixes the boot problem, then we go ahead and report it. And that's where we could really use help. This is what Kevin and I do every time there's a boot failure. And so it's kind of, some days when you get 40 boot failures on Linux Next, there's a lot of work to do. And then what happens is if we don't get them reverted quick enough, other issues kind of pile up. And so once we get the fix that reverted, then there might still be failing for other reasons that we have to then bisect again. So getting these things identified quickly and get them reverted.
Do you have like a maintainer board, like a contact?
Typically, that's who we usually go after when we find it. Other times, we'll actually reply directly to the patch in the mailing list saying, hey, the bot found this, we bisected it to this patch, reverting it, fixes the problem. So if it's specific to a board, we'll usually CC the maintainer if they didn't write the patch, just so that they're involved in the loop. And like the guys from Freescale have been really good about this. Fabio Esteban he's watching the mailing list pretty good. And after I give him a bisect report, he'll just send the revert commit right away.
And we have a handful of the ARM subarch maintainers are actually watching these email reports and actually becoming kind of our main users of kernelci.org. So that's been, from the beginning, it's kind of been the target audience, and more of those folks are using it. And so sometimes they see stuff before we even bisect it and reporting fixes. Usually, we're still finding stuff first. It hasn't quite got to the point where people are fixing stuff before we report it, but hopefully that's the goal. What else do we need to do here? Yeah, I guess we've kind of covered this. One of the areas we want to also do, it's already been brought up, is basically adding toolchain variations in this. Right now we're doing everything with essentially just kind of static toolchains. But we want to add another dimension to this and start doing all this stuff, but then add 3 or 4 toolchains to it, which kind of explodes the data set as well. So we were just before this meeting, Tyler and I were talking to the toolchain team about how to do this and how to go about this, because it's definitely an interest.
Typically, what is the data that you feel like is the most important? Just the raw boot logs? Obviously, attributes are not going to take up that much space, but is it the raw boot logs that you value the most? Typically, what have you found?
I think the most valuable stuff is new failures. What's new? What failed today that didn't fail yesterday? I think that's the most useful data.
That's kind of why we put the data together. It gives us a way of seeing that visually, right? Because typically what we do now is we look at if there's a failure, and you can go back to the bisection table, and it'll tell you when it was last working. And if that was like yesterday, then you kind of know, okay, this is a new failure today. But hopefully the delta views of the comparison view will give us that.
So do you have, like, when you do yesterday versus today's build, you had the boot logs, do you have like, okay, the only thing that I see different between yesterday's log and this log is this particular line? Do you have a view that does that?
No.
Yeah, probably want to do that, but.
Okay.
Yeah. I don't know how helpful that is, because usually we just want to bisect it right away and see what it comes up with. But yeah.
10-minute warning.
Can you talk a little bit about what it takes to set up a lab to talk to the kernel CI stuff?
Sure. So if you set up a Lava server with Lava devices, that's it. What I'm typically doing right now, like what the Collabra guys have done and what the validation lab does, is I set up a user and I have a hook. So once the builds are finished,
it just starts, it's threaded, so it just sends all the jobs to the different servers and waits for the results to come back. So if you set up a Lava server somewhere, you say, here's your username and your key. I use the API, and I directly interact with the Lava server, submit jobs.
You've got to be able to fix IP then.
Well, yeah, you need a host name, obviously. If it's a dynamic IP address, it's a little bit of an issue, but there's dynamic DNS for those kind of things, right, that can take care of it. So, but if you want to use any other framework, like if you have your own homebrew scripts, we have an API that we can go through that shows you, we can break it down, like basically you need to go find when there's new builds, and we have an API to do that. And once you found a new build, you need to somehow download the build and then boot it. And then we have a well-defined interface for what a boot report looks like. It's a JSON encoded file. So you put in the various bits there, whether it passed or failed, and then you use a post request to send it to the back end. And so you could, if you have your own scripts and you already have this working, there's a chance you could integrate it. Also, Highboot works out of the box with this. This is Kevin's and a lot of scripts that they put together to do.
Yeah, so all the labs that we have reporting now, 4 of the 5 are using Lava. Mine's the only one with homebrew scripts.
And the limitation right now currently is that Highboot can't run any tests. So as we start to move to testing, I think we need to either develop a solution for Highboot or we move to Lava to do that.
The other thing that doesn't work with Highboot is the automated, all the devices you can select from this nice little bisect bot won't be able to bisect on my boards because it's not integrated. So I think I'm probably going to move my setup to Lava. It just takes a bit more work. So I think we're pretty much out of time.
Alex?
So yeah, there's the links.
I just saw you list all the all the reasons for all kinds of configurations. Maybe many configurations just fail for one reason, and
yeah.
So maybe I just think maybe it's possible to start a fleet and to organize those result output. You can just list the real reasons, like something undefined, and put all together for all failures config and put together just behind those reports, and that will make it more clear at the same time. For
Yeah.
looking.
So are you talking about the email report? This kind of streamline the email report when there's one or two things that are causing all the failures.
Yeah, I also saw the web page also is hard tracking.
I see. Okay. Yeah, that's a good suggestion. Yeah.
Yes. Another, I still don't catch why cannot we do the bisection automation?
So we need to develop an API that will tell my bot that there's new work to be done. That's the part we don't have. But to do that, we need a way of detecting a new failure. And I think that's what we're going to eventually work on.
I think maybe just after the failure happened and all the testing was done, so your machine will have time to do the bisection. And to connect those kind of semi-automation, you can write some script and to do these things just triggered from a failure, and if other testing was done.
Yeah, and that's exactly, that scripting part requires an API. Unless you want to download you download the latest build from the API, and then you'd have to work out that's the hard problem is, what was the last build? With Linux Next and mainline, it's pretty simple, but with like stable and things like that, it's a little trickier because they have different versions. So you have to just also know, okay, what version of the kernel am I on, and then what was the last version of stable. So once we get that worked out, I think that absolutely will be what we do, is we create a script to automate that once we can get the workloads from the back end.
That's to check what is the last build, last release is supposed to be used by some script. If you find there are no updates like a certain time, a couple of hours, and then you think that is failure commit will be the last commit. So what is the bisection?
Yeah. So that's where we want to get to, but we're just not there yet. I think that's a great idea, especially build bisection might be interesting as well. We don't have that set up either.
Yeah, because I think you're talking about build bisection, and we've been only focusing boot bisection right now. But I think we're pretty much out of time. So there's some links up there for more details, and of course just go to kernelci.org and tinker around and let us know what you don't like, what looks funny, and what could be better. So, thank you very much.